Hi Year 9, this is the first in a series of 4 videos for the topic numbers of any magnitude. In this first video we're going to look at significant figures. So sometimes when we calculate with numbers, the answer that we get has many decimal places, and you've probably seen that on a calculator readout before. But this level of accuracy can have little meaning in real life. Now it's always good when you get to start with a Dilbert cartoon. This one says, I didn't have any accurate numbers, so I just made this one up. $4,629,873. Studies have shown that accurate numbers aren't any more useful than the ones you make up. How many studies showed that? 87. So how do we know how accurate to make an answer, and what methods are there for rounding numbers? Now we can round numbers to a specified number of decimal places, and you've been doing this since year 7, or maybe earlier. So suppose we want to round this number to 3 decimal places. We locate the position. There's the first decimal place, the second one, the third one. So we want to chop this number off after the 2. So we look at the next digit. Now here's the rule. For 5 and over, we round up. Under 5, we round down. So this is 5, so it's going to round up. It's too big to throw away. So that's going to force this 2 to become a 3. So it's going to be approximately equal to, that's what this sign here means, 8.973. How about this one? 2 decimal places. Locate the position, first decimal place, second decimal place, look at the next digit. It's a 2. This time it's under 5, so we're going to round down, which means that that 7's going to stay a 7. The 2, 5, 9, blah, blah, blah is all just going to disappear. So it's approximately equal to 8.97. How about 1 decimal place? Locate the position just after this 9. The next digit is a 7, so that's going to round up. And that's going to make this 9 into 10. But we've got a bit of a problem, don't we? Because 10 won't fit here. So it's sort of going to have a domino effect. The 9's going to become 0, and the 1's going to come over and add to the 8. So it's approximately equal to 9.0. And then finally to the nearest whole number, we're going to stop it here. Look at the next digit, it's a 9, it's too big, it's going to round the 8 up to 9. And you'll notice something curious here. We've actually got the same answer to both of these. So this rounded up to 9.0 and this rounded to 9. And that can sometimes happen. But another method of rounding is to use significant figures. Now all non-zero numbers are significant, but if a 0 occurs between 2 non-zero numbers, then it is also significant. Let's have a look at this number here, 0.002056. Okay, these zeros here are not significant. They're placeholders. But all of these are significant, including this 0, because it's in between 2 other significant figures. So we would say that this number has 4 significant figures. So let's see if we can figure these questions out. How many significant figures do the following numbers have? 123,456. There are 6 significant figures there. How about this one? 0.00123. These zeros are not significant, but this 1 and this 2 and this 3, they're all significant, so it has 3 significant figures. And then finally this one, all insignificant. The 2, the 0 and the 5 are all significant, so there are 3. Now the other thing we can do is write a number to a certain number of significant figures. So suppose we want to write 1,345 to 3 significant figures. So we want to keep the 1, the 3 and the 4. We look at the next digit, which is a 5, and we decide whether that is too big to throw away or not. So it's exactly the same as what we did with decimal places. Now the 5 is too big to throw away, so we're going to round up. So this 45 is going to become 50. So 1,345 is approximately equal to 1,350. How about this one? We want to keep the 1, the 3 and the 0. Look at the next digit, 7. Too big, so we're going to round up. So that 7 is going to round this up to 1. Or 798 is going to become 1,000. Either way, it's approximately equal to 131,000. Now let's look at this one, 0.006871. Right, so we want 3 significant figures. That's the 6, the 8, and the 7. The next digit is a 3, so we can just throw that away. So it's approximately equal to 0.00687. Now notice how I didn't put the 2 zeros on the end. That's because we don't need to, because it's actually a decimal. Here, the zeros are placeholders in the units, the tens, and the hundreds, but we don't need them after here. Can you see the placeholders in this number? Here and here, tenths and hundredths. What about this one? Okay, we want to keep the 1, the 0, and the 4. The next digit is a 5, too big, so we're going to round up that 4 to a 5. Approximately equal to 0.105. And lastly, how about this one? 120,029. We want the 1, the 2, and the 0. Looking at the next digit, it's a 0, so that's too small, we can throw it away. So this is all going to go down to 0, 0, 0, approximately equal to 120,000. See something unusual about that one? We've actually only got 2 significant figures, but it's still correct. We did write it to 3 significant figures, even though the third one is a 0. So how many significant figures should we use? Well, in general, an answer should never be more accurate than its least accurate part. Now, what does that mean? Well, suppose we've got this formula, pi r squared h, and we're going to work out the volume. R is the radius, and h is the height. And suppose our measurements are 12 centimetres and 35 centimetres. Now, both of those measurements are written to 2 significant figures. And so when we work out our answer, we should round it to 2 significant figures. Suppose our measurements were 3 significant figures. When we work it out, we should round to 3 significant figures. Let's finish with one more example. A rectangular room has dimensions 4.449 metres by 9.823 metres. What is the area of the room? Now, both of these measurements are to 4 significant figures. So when we multiply them, we should approximate them to 4 significant figures. So that means keeping the 4, the 3, the 7, and the 0. Looking at the next decimal place, it's a 2, so we can throw that all away. So it's approximately 43.70 metres squared. Now suppose we round the dimensions to 2 significant figures. Then what will be the area of the room? So we're going to do 4.4 multiplied by 9.8. So that gives us 43.12, but this time we're going to round to 2 significant figures, which is approximately 43 metres squared. Now you can probably see that a certain amount of error has crept in here because we've rounded, and that's going to be the topic of our third lesson. Okay, that's it for this lesson. In our next lesson, we're going to look at units of measurement.